here on API security. I'm glad to see so many of you have chosen this over lunch. So I'm going to try and talk about API security by design here, and one of my major incentives is to convince you that security is not as difficult as many make it out to be, and it's not really as much of a chore as you might think. We're going to go through a little bit of security foundations here. That probably won't be really necessary for the crowd here at InfoSec. Then we're going to make a little bit of a threat assessment exercise, which I find very instructive regarding APIs. We're going to go around sort of the environment in which APIs are developed and what that means for security, and then we're going to talk a little bit about the process and tools that you might use for securing your APIs. So I'm Timo. I'm the VP of Product at Firetail. I used to be a theoretical physicist until I decided to do something slightly more challenging, like writing maintainable JavaScript code. I've been at a few other startups before this, and now indeed I'm focused on making APIs secure. This is the thing that everybody who's tasked with API security knows about. Winter is coming. API security is a rising cause of incidents year over year, and people who need to secure APIs understand this is just the beginning. It's just the tip of the iceberg. Obviously, it did take these guys 7 seasons to actually show up, so maybe this is a little bit hyperbolic. But overall, I would like to sort of motivate you by thinking about the fact that the entire industry has changed dramatically. We've gone from monolithic applications to microservices. We've split out non-business critical functionalities like payments and fleet management and other stuff to third-party services. All of these are communicating via APIs, and that means that if you look at sort of normal internet traffic, over 80% of internet traffic today is just API calls between different machines and different services. And these services are talking to each other, and they're communicating actually valuable information. They're communicating personally identifiable information, your address, credit card numbers, payment details, etc. So this sort of value that's moving about is attracting attackers, and that's why we're seeing year-over-year growth in what we would call API or pure API incidents. We've got an incident tracker up on our website if you're interested to take a look at the research that we've put in there. So let's take a look at a little bit of sort of very, very basic security. This is the CIA triad. It's very well known. I personally like availability the most because it's the thing that is usually forgotten about. And sort of quite important, because if you didn't need availability, it would be very easy to secure your data. You just carve it into stone tablets and sink it into the Mariana Trench, and that'd be done with it. But these may sometimes seem like a little bit of abstract and sort of high-level concepts. And I find it useful to have like exercises like this, where you take the OWASP top 10 list and you attach each item to what they actually represent in this sort of framework of these high-level concepts. And you very quickly find that you can take a look at any sort of kind of threat list, and you see how it connects back to these very sort of fundamental aspects of security. So that's sort of like the first takeaway that I would suggest to you, is that when you're thinking about security, it's not necessarily about any individual sort of to-do list or task list. It's about understanding the fundamentals in there and sort of thinking about, how do I make my API available? How do I ensure that it remains available? How do I make sure that it's confidential? How do I ensure authorization and authentication, for example? So let's take the OWASP list and make a little bit of a threat assessment exercise here. And this is sort of intended to make you understand, sort of given a certain picture of the threat landscape, where to spend your time when you're thinking about securing your API. So this is a little bit of a schematic here about an API call. You've got a consumer doing a request over an internet connection. There's a gateway with some traditional network security aspects in it. and then you get into sort of the authentication step, and then the server deals with the request and returns a payload. The one thing already in this graph that some people seem to forget, and some people forget at their own peril, is that once you have the sort of payload prepared and are sending it back, you need to do all of these steps again, like validation, sanitization again. Otherwise, you're basically trusting your business logic, you're trusting the code to only return information that's authorized. And that can sometimes not be the case if database models change and suddenly there's unique identifiers in there that shouldn't be exposed. There have been cases where that is not. So off the OWASP 10, we're going to skip 2 items which are more about configuration and maintenance of APIs. They don't affect a single API call, but then we can start with the second one, for example, which is broken authentication. I singled this one out because it is usually separated out into a third-party service. It's one of those things that we normally abstract away, but it also can be handled with the server. That's why it's sort of in the dashed line there. But the next ones are then unrestricted resource consumption, unrestricted process access. These are, again, I want to go through these second because most this is why you have rate limiting and WAFs. These are items that are sort of counted as things that you can deal with by using traditional network security. However, I would say that that's not always the case, especially in sort of services that are using, for example, GraphQL. It's more about the validation of the request and the actual business logic executing the request, because it's not about having requests come in at a certain rate that's too high, for example. It's about the requests themselves being able to have a parameter in them that just requests 1,000 items or 10,000 items or 1,000,000 items, right? And that is stuff that can't be dealt with at the sort of WAF at the gateway or the proxy level in front of it. And then comes the big hitters. This is authorization, this is bolus, and property level access and function level access, which is not directly authorized. These are classics, and these are like the primary cause when you're looking at incidents. Again, I encourage you to take a look at the incident tracker. We do separate out primary causes and secondary causes for incidents, and the primary causes, the biggest share of them are due to incorrect authorization. And then finally, there's server-side request forgery and unsafe consumption of APIs, which obviously are also being dealt with at the application level. So what this sort of picture tells you, interestingly, is that the sort of 2 most important causes for incidents that we see are both at the server level, and indeed the bulk of everything that is sort of being enumerated in the OWASP 10 list has to be dealt with at the application level by the business logic or by proper sanitization and validation of your requests. So if you're asking yourself where do you spend your time improving your API security, it is that layer that you need to focus on. We tend to say that traditional network security doesn't cut it in the modern threat landscape. And that doesn't mean that you shouldn't do SSL protection of the connection there, or you shouldn't have a WAF and a rate limiter in front of your API. But it does mean that for these sort of incidents that we're seeing, like the malicious traffic looks like well authenticated, correct traffic, and that does not get blocked by those traditional methods. So the next thing that I want to step into is a little bit about the sort of environment where the APIs are being developed, and sort of look at the landscape there. So there are 2 things that are sort of fundamental and very basic. One is that your API has a lot of different users. It's not just about the consumer of the API and you as the developer of the API. There's a DevOps team, there's a marketing team, there's your support team, there's a security team. There are all these sort of different stakeholders that might have a say or might have some needs for your API to do certain things, right? And the other thing is the sort of API lifecycle, which is slightly abstracted and very minimalized here, but you've got the design, development, deploy, operate system, and then obviously the retirement bubble there is one that catches on people sometimes. But these two things are quite fundamental, not unique to API development, but sort of general in the sense of software development. And these two things bring about two of the sort of main concepts that I want to emphasize here. One is documentation. Just the existence of many stakeholders means that the primary thing that you should focus on when you're sort of thinking about your API is have good documentation for your API. Having a single source of truth helps all the stakeholders agree on what the API should be doing. And it helps different stakeholders not having to ask everybody all the time about what this one endpoint should actually be doing. It codifies your business logic and lets everybody be on the same page for this. The other thing that's important that has to do with the life cycle, and this is one that, out of personal experience, I can tell you that the first time you have a feature hit the retirement bubble, you immediately notice that you should have done versioning. And if you don't do that in advance, that's also really hard to retrofit into your application. So this sort of like hellhole of boxes appears when you spread out these two factors and sort of think about what all these different boxes contain. I've highlighted the sort of central one there, which is the development team working on the API during development. That is what most people focus on when they think about API security. And I mean, it's a good reason. Like we did the threat exercise just a few seconds ago, and it tells you that that is where you should focus. But there's all these other parts that are also quite important. And if you do risk analyses for all of these parts, you can see that there's like bad things happen if you are lax on those. So let's see if we can get through this. It might seem daunting to have all of these things here, but I'm trying to convince you that it's actually not that bad. So usually when you have like new